Hello dear friends and students. As we all know that logarithm is a very important topic embedded in almost each chapter of maths and various chapters of physics and chemistry. My name is Yogeshwar Singh and I will be teaching you the basic concepts and applications of logarithm. Let's start with why do we need logarithms? First is, in mathematics, physics and chemistry, there are some numbers which are either very big or very small. For example, speed of light, radius of atom, etc. To perform operations on such numbers is a difficult task. And second is, lots of things in our normal daily life involve logarithmic graph in their normal behavior. For example, hot objects cooling down, cold objects warming up, etc. Let's go with first of all the representation and meaning of logarithm. In exponents, we say that if a number a is raised to the power x, we get a result y. Here we call the number a as base, x as exponent and y as a result. This means we have to multiply a x number of times to get y. Let's see how this gets converted into logarithm. In logarithm, we convert this exact expression into a different arrangement. We say that logarithm of y to the base a is x. That is, if we take log of the result to the same base, we get the exponent. That is, logarithm is a process to give us the exponent. Let's study the properties of exponents, which you have already studied in lower classes. We'll quickly go through the properties. First property is x to the power 1 is x, that is any number raised to power 1 is same number. Any number raised to power 0 gives us 1. If we raise negative powers of a number, then the number goes into the denominator. If we multiply same number raised to two different powers, then the exponents are getting added. I have given you certain examples on the right hand side. You can stop this video and look at these examples. Now the next property is x raised to the power m divided by x to the power n is equal to x to the power m minus n. X to the power m whole raised to the power n is equivalent to x to the power m into n. X into y whole raised to the power n is equal to x to the power n multiplied by y to the power n. X by y whole raised to the power n is equal to x to the power n by y to the power n. The last property is x to the power minus n is 1 by x to the power n. You must remember all these properties to have a grasp on logarithm. Now there is one more property which involves the fractional exponents. Here we say that if a number x is raised to the power m by n, that is a fraction, it can be written as nth root of x to the power m or nth root of x whole raised to the power m. It doesn't matter in which order you are taking the x powers, you'll get the same result. Let's see the graphs of exponential function. Here y is equal to a to the power x is an exponential function. A is a fixed number which is called the base, and x is the exponent which varies from minus infinity to plus infinity. As in this graph we can see that when x is varying from minus infinity to plus infinity, it is continuously decreasing from plus infinity to 0. Remember, this graph never touches the x-axis. Second point to remember about this graph is that the value of y is always positive. It never goes below the x-axis. Next is when base is greater than 1, then the graph behavior of the graph is almost the same. Its graph is just mirror image of the previous graph about y-axis. If you take the mirror image of this graph in y-axis, you will get this graph. Here, when the x is varying from minus infinity to plus infinity, the value of y is increasing from 0 to infinity. In both the cases, y always remains positive. Let's do some questions based on the properties I have explained you. First question is solve for x under root of 3 by 5 whole raised to the power 1 minus 2x is equal to 4 whole 17 by 27. Answer is x is equal to 7 by 2. And this next question is, if a to the power x is equal to b to the power y is equal to c to the power z, and a relation b square is equal to ac is given, then you have to prove that y is equal to 2xz upon x plus z. Now let's look at the solutions, but I would recommend that you pause the video first, solve these questions, get the answers, and then you can proceed on to the next slide for the solution. As far as the solution of first part is concerned, we are being given that 3 by 5 raised to the power 1 minus 2x whole root is equal to 4 whole 17 by 27. This is a mixed fraction. First of all, you need to convert it to a proper fraction, that is multiply 27 into 4 plus 17 is equal to 125 by 27. I hope you all must be aware about this conversion. After doing this, we observe that on the LHS we have 3 by 5 raised to the power 1 minus 2x by 2, and on the RHS we have 5 by 3 raised to the power 3. Here the bases are not same, so you cannot equate anything right now. You have to first make sure that both the bases are same. So what we do, we write RHS as 3 by 5 raised to the power minus 3. Therefore, now it becomes 3 by 5 raised to the power 1 minus 2x is equal to 3 by 5 raised to the power minus 3. Now, both the bases are same, and if we are raising same number to different powers and getting the same result, then it means that both the powers should be same. So, we say that 1 minus 2x by 2 should be equal to minus 3. Remember, we can say this only if this base is not equal to 1, because 1 raised to any power will always give you 1. So you cannot say anything about these powers if the base is 1. You have to make sure that the base is not equal to 1. Now equating the powers, 1 minus 2x by 2 equal to minus 3, we get x is equal to 7 by 2. This is the answer for the first question. Now let's move on to the second question. This question is a very particular question. Here you have been given that three quantities are equal to each other. In almost 99% of the questions of this kind, you have to assume that all the quantities which are given equal, let it be equal to k, and then convert every one of them into the same variable. A to the power x is equal to k means a is equal to k to the power 1 by x. Similarly, b is equal to k to the power 1 by y, c is equal to k to the power 1 by z. Put all these three in the given relation b square is equal to ac. You will get k to the power 2 by y is equal to k to the power 1 by x plus 1 by z. Please note, here we have to make sure that the value of k is not equal to 1. If this is equal to 1, then x, y, z could have any values. But if the question is given, then we have to assume that k is not equal to 1, and then we can say that if base is not equal to 1 and both the values are same, then the exponents must be same. Therefore, we can say that 2 by y is equal to 1 by x plus 1 by z. On taking the LCM, we get y is equal to 2xz upon x plus z, which is the required result. Now, we will be seeing some properties of logarithm. Before proceeding to that, we need to understand this conversion. Remember, my friends, this conversion is very, very important. That is, if a to the power x is equal to y, then log of y to the base a will give you x. I will give you some examples regarding this. For example, 2 to q power 3 is equal to 8. It means if we write it into the logarithmic terms, then it can be written as log of 8 to the base 2 is equal to 3. We get the exponent as the answer, remember. 7 to the power minus 2 is 1 by 49. Therefore, we can say that log of 1 by 49 to the base 7 is equal to minus 2. Suppose you are given, you have to find the value of log 5 to the base 25. Here we have to find a power of 25 to which it should be raised to get this number. So what we do, we assume it equal to x. This implies that when we convert this into exponential form, we get 25 raised to power x is equal to 5. 25 raised to power x is equal to 5. Now 25 is 5 square, so 5 to the power 2x is equal to 5 to the power 1. 5 is not equal to 1, so we can very safely equate the exponents, and hence we get x is equal to 1 by 2. Let's solve one more question which is a little bit difficult. You have to find the value of log 144 to the base 2 root 3. Again, I will recommend you pause the video, solve the question, get the answer x is equal to 4, and then check your solution. For solution, what we do, we let it equal to x, and we all know that 2 root 3 is equal to root 12. When 2 goes inside the root, it becomes a square, therefore 4 into 3 is 12. So now we see that root 12 is in the base, 12 square is in the number which we have taken the log. Let it be equal to x. So by conversion property, we can convert it as root 12 raised to the power x should be equal to 12x square. So 12 square is equal to 12 to the power x by 2. 12 is not equal to 1. Therefore, we will say x by 2 should be equal to 2 or x is equal to 4. I will be ending my first lecture. In the next lecture, I will be explaining the conditions on use of logarithm and properties of logarithm. Please do subscribe to my channel YLC, that is your learning curve. Please don't forget to press the bell icon, and if you have any suggestions on how to improve and go about it, please do suggest in the suggestions box. Remember, practice makes a man perfect and there is no substitute for hard work. Thank you for watching.